Hello, everybody. Welcome to another sprint demo from the Evernym team that contributes to Indy and Sovrin. We're excited to show what we've got done over the last couple of weeks. As an introduction, this week, the most important thing we got done is that our team in Russia, in Voronezh, enjoyed some rest and relaxation. There's a lot of holidays this sprint, so they were able to take some time off. And we did get a lot of work done, but we expected to have a smaller sprint than normal in order for them to take that time off, enjoy their spring holidays. So with that, on the SDK side, we didn't get as much done on the credential exchange hype as we'd hoped. We hope to get some more feedback incorporated over the next couple of days there. But we did evaluate a vulnerability with ZMQ, found that it does not apply to our deployment. Made a lot of progress on the transaction author agreement and improved the way multi-signatures happen. So that's made good progress there. On the Indy Node side, we got a stable release out, a really large one. It ended up being called 171 because we found a bug in the release candidate. So that's out. It's got the auth rule support, and it's got the multi-signature work, and it's got the audit ledger. So we're excited about that. That is being currently deployed to the Sovrin network. I believe it's on BuilderNet now, and it's going to move to StagingNet next on Monday. So it's looking good. We're really proud of the work that we got done there. So thank you, team. Then we continued our work on getting the transaction author agreement support on Indy Node. Made good progress there, and further improving the way auth rules work to have better test coverage and some cleanup and bugs there. On the next step for the auth rule support is to get the Sovrin Token implementation to support the new approach. And so we've been making progress on that. We got an updated plugins release out, and then we made progress on getting support for the new auth map, the new auth rules in the token-related transactions, minting, transfer, setting fees, getting fees. And we did a plan of attack for how we want to support getting fees with this more complicated set of rules than we've had in the past. So that's what we got done. Pretty good set of stuff. So Alex is going to talk to us about the transaction author agreement design and how that's going to impact people over the next couple of months. And then we'll talk about the SDK side of the transaction author agreement API, and then we can talk about the Sovrin Token plugins. So that's what we'll do. So I'll stop sharing my screen. So you can share, Alex.
Okay, thank you. So this sprint, we started a big epic related to transaction auth agreement, and we finished the design for this feature. As usual, you can find the design in a design folder on GitHub. It's public, and you can see it, it's in Indy Node design folder. So what is transaction auth agreement and why we need it? There are some legal nuances, legal things that users write some data to the ledger, and ledger, as any other blockchain, it's immutable. So no data can be removed from there. And that's why something like agreement that the transaction author understands all the consequences of this is required for a lot of use cases, and in particular, it will be applied to Sovrin network. And in order to fulfill this requirement, we are going to add the validation that the user signed the transaction author agreement, that understands the agreement and signed it, into the validation procedure by the ledger. Moreover, there will be a special, that transaction auth agreement itself will also be anchored to the ledger. So the text of agreement will be accessible from the ledger. There will be a special new transaction to set this agreement there. And also, we are going to introduce the notion of acceptance mechanism list, and this is the description of how the user accepted this agreement. It can be EULA, it can be just click in the application, and so on. So, as part of this plan, we are going to support multiple things in Ledger, Indy Node side, and in SDK side. As for Indy Node side, we are going to support three main things. The first thing is that the ledger needs to have a capability to store the transaction auth agreement, and this will be a new transaction. The second thing that the ledger will store the acceptance mechanism for this agreement. And of course, there will be the methods to query to get them from the ledger. And the third big thing is that the validation will be extended so that the transaction auth agreement is included into every request, signed. The hash of the agreement is signed, and it's verified by the ledger that it's really a correct one. So as I said, the plan is the following. The ledger will store the transaction auth agreement transaction. This is a transaction in config ledger. So we have multiple ledgers, and config one is a good place for this kind of information. And of course, it will be stored, transaction auth agreement will be stored in config state tree for efficient querying. You can see that the key in state will be a digest of this agreement, and the value will be the text of agreement and the version. And also will be a number of helpful indexes for querying by version and for querying by the latest transaction auth agreement. Also, there needs to be a possibility to query the agreement by timestamp.
Hey, Alex, is latest a Boolean then? It's set to true or false?
No, it's just a way to get the latest, the current transaction auth agreement from the ledger.
So it's an API for
yes.
It's
internals how it's stored in state tree, Patricia state tree. It's like a key value storage, and that is just a key which is called latest, and the value
it's always updated to point at the most recent one.
Yes, exactly. So this is just for an easy way to get the most recent, the most current transaction auth agreement, because usually this is a most interested transaction auth agreement for the user, and also it's one that the ledger will perform the validation against, at least according to the current requirements. So the transaction auth agreement transaction will consist of the text of agreement and the version. The version is a unique identifier. There will be a get transaction auth agreement command request, and it can get it by digest, by hash. It can get it by version, or it can get it by timestamp. And if no parameter specified, then the latest version of transaction auth agreement is returned. The second transaction on the ledger is a transaction auth agreement mechanism list, and it has the following format. Also, it has a description of every mechanism. And the next thing is how this transaction auth agreement is verified. And the important thing here is that, well, first of all, if there is no transaction auth agreement set on the ledger, then it's not required, and everything works as it's now. But if transaction auth agreement is set to the ledger, then all requests, at least from the domain ledger, must have this new metadata in their requests. It's called TA acceptance, and it includes the digest of the agreements they signed. It includes the mechanism they used. For example, they clicked agreement or agreed with the EULA, and it includes the time of acceptance of this transaction auth agreement from the client point of view. And the ledger is going to verify that the agreement that the user signed is really the latest one, and that's valid mechanism is used, and the time is also valid. So the validation, this information will be validated by the ledger. There will be the corresponding API on libindy side, and Sergey will tell more details about it. The final thing here is, for example, if we have a requested transaction and we would like to verify that the transaction auth agreement was really valid at the time of writing this transaction, then the following steps can be done. So we can get the transaction we would like to audit from the ledger and extract the digest of transaction auth agreement, time of transaction, when it was written to the ledger, and time of acceptance. Then we we get the corresponding transaction auth agreement and mechanisms list at the time for the time of transaction, and make sure that that digest of this transaction auth agreement come equal to the one specified in request, and verify that the time is really correct. And also we make sure that the mechanism was in the list of the current mechanisms at the time of this transaction. So,
and just so
yeah.
I think it's worth defining for any viewers of the video, the acceptance mechanism is we want the user to say how they accepted the agreements. We don't want them to say which software package they use, because then they can be correlated. But we want them to say, you know, I clicked the agreement, or it was part of my service provider EULA, or it was part of a cloud offering that I'm using. That way, if they were to ever challenge the transaction auth agreement, there's a little more evidence that they did go through the process of knowingly accepting it. Yeah. So there's going to be a list on the config ledger of which of those strings are valid, and that'll be set by the Sovrin Foundation, who will be using this functionality.
Yeah, it will be done by this transaction auth agreement AML.
Excellent, Alex. I think it's a really well thought through approach to this problem.
Okay, thank you. So I believe Sergey can show us some examples of this new API.
Thank you. So let me share my screen. I'm going to talk about IndyZK part of this task of transaction auth agreement, and which new API call implemented in our code base. We decided to have monolithic design for both IndySDK and Indy Node paths. So you can find details about IndySDK API inside Indy Node design folder. And in fact, we have two groups of new API calls in libindy. The first one group is about more or less regular transaction, like write new transactional agreement to the ledger, read the latest or some specific version of transactional auth agreement from the ledger, and similar functions around acceptance mechanism list to set acceptance mechanism list from network maintainer, or to read acceptance mechanism from the ledger from regular user point of view. It contains regular fields like submitting the ID for write request, and the actual data about transactional agreement like text and version. For reading that author agreement from the ledger, we are allowed to multiple way to do it. There is a data parameter in call build get and author agreement request, and the user can choose one of the strategies. The simplest one is to just skip this parameter and pass null to this parameter. In this case, libindy will build a transaction a request to the ledger, which would fetch just the latest version of transaction offer agreement. And we suppose that will be the most popular case. But if user would like to fetch something different from the latest version, he can specify either a particular digest of this transaction offer agreement or try to fetch the TA text based on version or timestamp when it was valid. Fetching by timestamp may be very useful for auditor activity. We have similar logic for acceptance mechanism list. I think it's not so interesting, so let's just skip it. And the second part of libindy API is special step how to append acceptance fact to the particular request. So let me jump quickly to the example. Previously, the typical behavior of client was like build some request, for example, build name request, and then just sign and submit this name request. But now, if the ledger contains transaction offer agreement and require to sign it, a new one additional steps is inserted between initial two steps. And now the flow looks like build some write request, append transaction offer agreement acceptance to this request, and then sign all this data. So signing will also includes as digest all information which version text was read by user and accepted. And now let's talk in details about this API call. It allows to different way how to user can tell to libindy which version in which transaction offer agreement was accepted. Application can pass particular text and version of the accepted document. And in this case, libindy will calculate digest of it and include digest into transaction to the ledger. Or application just calculate digest by itself for some reason, maybe for caching or to double check the actual digest. And this digest will be passed through libindy API and appended to write request to the ledger and then verified by the ledger. And there is one more option here that all these three parameters, I mean text, version, and digest, can be passed by application. And in this case, libindy will verify consistency of passed text version against the digest. In any case, this libindy API call will append to initial transaction acceptance metadata, acceptance data mentioned by Alex, like time of acceptance, digest, and acceptance mechanism type to the write request. And then application will call sign. Acceptance data will be signed by DID-based signature and pass it to the ledger. Also, there is some corner case about some payment requests, but I think we will talk about this specific in the next sprint. Then we will have implementation in Libs of token. Of course, we have to update Indy CLI and V6. So you can find some information in this document about that. And I hope we will have, after we will finish integration between Indy Node and Indy CLI about transaction offer agreement, we can show demo about how it works from CLI point of view. For now, we have initial implementation of transaction author agreement merged to Indy SDK master. You can find this new API in master libindy ledger file, and we have some unit and basic tests on that, but integration is a subject for the next hour sprint. I think that's it from my side.
That's really great, Sergey. The stewards of the Sovrin network have approved, they requested the support for the transaction author agreement. They've approved enforcing it on the Sovrin network as soon as it's ready. Our goal is to have it ready in the next couple of weeks, but all the users of the network then have to go ahead and accept that agreement. So we don't know when it's going to start being enforced, but we wanted to make sure that the API design was available to people immediately so that you can start to prepare to update your application to handle the transaction author agreement, or else you're not going to be able to write to the Sovrin mainnet. Whether that's June or July, I don't know, but it's going to be fairly soon. So please let us know if you have questions or need help getting your applications updated. So thanks, Sergey. Last topic for today is Renata is going to take us through the improvements to the fees mechanisms for auth rules, or the improvements to auth rules to support fees.
Yes, let me share my screen. In the scope of those three tasks, authorization of XFIR, set fees, and mint transactions has been added through a new authorizer from Indy Node. In soft token fees, the plugin was added soft token fees outmap with a rule for the set fees transactions. To send a transaction of this type, signatures of 3 users with the trustee rule are required. And in soft token plugin was added soft token outmap. With the rule for the mint public transaction, required signatures of 3 trustees, and XFIR public transactions, signatures are not required. Although the list of requirements remains the same, but now dynamic rule editing is available via an auth rule transaction. Start a node without plugins. Create the node, initialize the map, and start a node. And now loading the node with plugins looks like this. Creating a node, initialize the map, adding soft token, and include soft token auth map in auth map from Indy Node. And soft token fees and enable soft token fees auth map to auth map from node. Start nodes with plugins, of course. Let's look at this maps in the code. Oh, sorry. It's a soft token fees map with rule for.
So we're still seeing your browser with the presentation in it.
Oh, and now?
No, I'm not seeing your code window. Your ID.
You should share the full screen.
I don't know how can I do it. Sorry. I will try again. Is it better?
Yes, that's what we expect. Yeah.
Thank you. Sorry. It's a soft token fees auth map with rules for editing set fees transaction, its action, and constraints with 3 signatures of trustee. And it's a soft token auth map with rules for add mint transaction and add XFIR. With constraints with 3 trustee and add Xfer without any constraints, without signatures. Let's start tests. And I don't know, do you see my screen now? Tests was written for this task. Test for set fees, test for mint, and test for Xfer. It's tests which change auth rule, send third trustee transaction, and check that validation failed because auth rule was changed. One moment. This test. And we change auth rule back to default rules and check that transaction with previous signatures with third trustee pass successfully. Test successful. That's all my side. Thank you.
Thank you. That's really great. And this should all be available at the end of May. The next step over the next couple of weeks is to update the way that fees are handled so that we can get the fees out of that auth map in a clean way. So I want people to be aware of ST 535, which contains the requirements and the API changes that will be necessary to make that work, as well as, so it's got a bunch of definitions, sets the problem out, and then a plan of attack for those API changes. So we'd appreciate people looking that over and letting us know if they think it's a good solution, any improvements you have. But most importantly, code's going to have to be updated to reflect the new way to get fees, since it's a much more fine-grained auth map than we had in the past. We're out of time. The next step then on the Indy Node side is to complete that support of the authentication, the new auth map, and getting and setting fees. And then completing that release of 180 that'll have the transaction auth agreement in it and the new auth fees. So that's the goal there. On the SDK side, we've been catching up on pull requests. We want to get the URSA pull request reviewed and try to get that into the SDK over the next couple of weeks. We got a bunch of bug fixes we need to do, and getting back to the credential exchange hype and thinking about the design of an SDK 2.0, or thinking about how we want agent-agent protocol support in the SDK is the next step there. And of course, we got to finish up the transaction auth agreement, get that stuff out. So that's the plan. Let us know if you have any questions, and of course, you can always reach us at chat.hyperledger.org and #Indy. We're always there well, we're frequently there to answer questions. So I'll stop the recording. Thanks.